Hello guys, welcome back to my channel Vivek's Math Class. Today in this class I am going to solve some example problems based on section formula. So before starting this class, if you are not subscribed to this channel, please do subscribe, press the like button and share the link to all your friends. Fourth question, find the ratio in which the y-axis divides the line segment joining the points 5, -6 and -1, -4. Also find the point of intersection. So let's solve this problem. Solution. We know that a point on the y-axis is of the form 0, y. We know that a point on the y-axis is of the form 0, y. For our convenience, we have to take the ratio as k:1 and not as m1:m2. Okay. So let the ratio be k:1. Now we have to write the section formula. The section formula is given by p of x, y is equal to m1x2 plus m2x1 divided by m1 plus m2 and m1y2 plus m2y1 divided by m1 plus m2. Here x1, y1 is equal to, this is the x1, y1, that is 5, -6, and x2, y2 is equal to, this is the x2, y2, that is -1 and -4. -1, -4, and x, y is equal to, this is the x, y, that is 0, y, and m1 is equal to k, m2 is equal to 1. Now let us substitute all these values to the section formula. Therefore p of x, y is nothing but 0, y. 0, y is equal to m1 x2. The value of m1 is k. The value of x2 is -1 plus m2 x1. The value of m2 is 1 and the value of x1 is 5 divided by m1 plus m2, that is k plus 1. Next, m1 y2. The value of m1 is k and the value of y2 is -4 plus m2 y1. The value of m2 is 1 and the value of y1 is minus 6 divided by m1 plus m2, that is k plus 1. This is the x coordinate and this is the y coordinate. That is p of 0 comma y is equal to k into minus 1 is nothing but minus k plus 1 into 5 is 5 divided by k plus 1. Next, k into minus 4 is minus 4k plus into minus is minus 1 into 6 6 divided by k plus 1. We know that when x comma y is equal to a comma b, then this x is equal to a and this y must be equal to b. In the same way, here this x coordinate is equal to this x coordinate and this term will be equal to this one. So first let us equate the x coordinates, that is minus k plus 5 divided by k plus 1 is equal to 0 divided by 1. Now let us do cross multiplication, that is 1 into minus k plus 5 is equal to 0 into k plus 1. So 1 into minus k is minus k plus 1 into 5 is 5 is equal to 0 into k plus 1. When we multiply 0 with any number, the answer will be 0 itself. That is, when we shift this minus k to the RHS, it will become plus k and this is 5. That is, the value of k is 5. That is, the ratio is k is to 1 is nothing but the value of k is 5 is to 1. Now we have to find out the value of y. For that, we have to equate the coordinates of y on both sides. That is, y is equal to minus 4k minus 6 divided by k plus 1. Now let us substitute the value of k here. That is, y is equal to minus 4 into the value of k is 5 minus 6 divided by 5 plus 1. That is, y is equal to minus 4 into 5 is minus 20 minus 6 divided by 5 plus 1 is 6. That is, y is equal to minus 20 minus 6 is nothing but minus 26 divided by 6. When we simplify, we will get 2 3s are 6, 2 1s are 2 3s are. That is, the value of y is minus 13 divided by 3. Therefore, the point of intersection is is given by 0 comma y is equal to 0 comma the value of y is minus 13 by 3. This is the answer. Fifth question. If the points a of 6 comma 1, b of 8 comma 2, c of 9 comma 4 and d of p comma 3 are the vertices of a parallelogram taken in order, find the value of p. In this question they have given 4 points of the vertices of a parallelogram, and now we have to find the value of p. Solution. To understand this problem, first we need to draw the parallelogram. This is parallelogram, and this is point A, point B, point C and point D. The coordinate of point A are 6 comma 1. The coordinates of point B are 8 comma 2. The coordinates of point C are 9 comma 4. The coordinates of point D are p comma 3. We know that diagonals of a parallelogram bisect each other. That is, the diagonals of the parallelogram is AC and another diagonal is BD. When the diagonals of a parallelogram bisect each other, then the coordinates of the midpoint of AC must be equal to the coordinates of the midpoint of BD. Okay. We know that diagonals of a parallelogram bisect each other. Diagonals of a parallelogram bisect each other. So, coordinates of the midpoint of AC must be equal to coordinates of the midpoint of BD. Midpoint formula is given by x1 plus x2 divided by 2, y1 plus y2 divided by 2. This is the midpoint formula. So, for AC, x1 y1 is, for the diagonal AC, x1 y1 is 6 comma 1, and for the diagonal and x2 comma y2 is 9 comma 4. Next, for another diagonal BD, x1 y1 is, for diagonal BD, this is x1 y1 and this is x2 y2. x1 y1 is equal to 8 comma 2, x2 comma y2 is equal to p comma 3. Now here we have to substitute the values of x1 y1 and x2 y2. So the coordinates of the midpoint of AC is given by x1 plus x2, that is 6 plus 9 divided by 2, comma y1 plus y2 means 1 plus 4 divided by 2. 1 plus 4 divided by 2. This is the midpoint of AC. Next, for BD, x1 plus x2 is nothing but 8 plus p divided by 2. Next, y1 plus y2 is nothing but 2 plus 3 divided by 2. 2 plus 3 divided by 2. That is 6 plus 9 is nothing but 15 divided by 2, comma 1 plus 4 is nothing but 5 divided by 2 is equal to 8 plus p divided by 2, comma 2 plus 3 is 5 divided by 2. Here the y coordinates on both sides are equal, so we have to equate the x coordinates of both sides. That is 8 plus p divided by 2 is equal to 15 by 2. Now let us do cross multiplication. 2 into 8 plus p is equal to 15 into 2. 2 into 8 is 16 plus 2 into p is 2p is equal to 15 into 3 is 30. That is 2p is equal to 30. When we shift this plus 16 to the RHS, it becomes minus 16. That is 2p is equal to 30 minus 16 is 14. If 2p is equal to 14, then p is equal to 14 by 2. So 2 ones are 2 sevens are. That is the value of p is 7. This is the answer.